Polynomial is a term and it contains variables, numbers, or both, a combination of both, that are connected by multiplication or division only. So you guys are familiar with monomials. You've seen them all the time. That's a monomial. Anything by itself, like any number or letter by itself, is a monomial, or any combination of letters and numbers connected by multiplication and division. Okay. Polynomials are expressions that have monomials separated by addition and subtraction. So if I take the monomials from the first example and I put addition and subtraction between them, it becomes a polynomial. Poly meaning many. That's the Latin root, and mono meaning one. The monorail at Disney has one rail.
So what about mono?
Mononucleosis?
Yeah.
Probably has one nucleus. I'm not really sure.
It's like crazy.
So it's one nucleus that like fucks you up for like 6 months?
I have no idea. So anyway, to simplify polynomials, you have to rewrite the expression with no parentheses, no roots, and all like terms collected. Okay, so we have some powers of exponents, products of powers. Okay, if you have two products with a common base, okay, so just to go over this, this is the base, this is the exponent. Okay, if you have a common base and you're multiplying them together, sorry, it's not xy.
Oh.
Wow, kind of just an ink now on my paper or whatever.
It's x plus y. Just put a plus between them.
They're too close.
Sorry. Sorry. So as example, let's say I have x to the 5th times x to the 7th. That's going to be x to the 12th. Yeah, you just add the exponents. Yeah. Quotients of powers. So if I have a to the x divided by a to the y, it's a to the x minus y. So for example, x to the 10th over x to the 6th would be x to the 4th. Okay. Negative exponents are not allowed. Right? So if I have a to the negative x, that's 1 over a to the x. And then just over on the side, if you have a to the negative x in the denominator, you bring it to the top. So for example, a to the negative 5th is 1 over a to the 5th.
Wait, when it's set up like 1 equals a, 1 not equals 1 over a minus x, you set up as a positive x?
Mm-hmm.
Okay.
Yeah, because you don't have negative exponents, so anytime you have a negative exponent, you take the reciprocal of it.
Okay.
So if it's already in the denominator, it goes to the top. If it's in the top, it goes to the bottom.
Is the one like canceling out the negative?
No.
No.
No. Basically, we're just taking the reciprocal. So anytime you have a negative exponent, you take the reciprocal. So if it's in the denominator already, the reciprocal of it is to flip it over.
Mm-hmm.
So if there was, say, for example, there was a 2 up there, 2 over x to the negative 3, this would become 2x to the 3rd.
True. Okay.
So you bring it to the top.
All right.
Okay. Powers of a power. You multiply them. So if I have x to the 3rd to the 5th, that's x to the 15th. Power of a product. You multiply whatever exponent is in here. So if it's just a 1, you multiply times 1. In my example, I'll do, so if I have, say for example, 2x squared raised to the third, that's going to be 2 to the third x to the 6th, which is going to be 8x to the 6th.
Wait, could you explain that again?
Yeah, so if you have an exponent on the outside of a parenthesis and there's a product inside, I'm going to take this exponent and apply it to each of these things. There's like an invisible 1 right there, right?
Right.
So it's 3 times 1, so that's where I get this third, and 3 times 2, so that's where I get the 6th.
Okay.
Power of a quotient. Same general idea. This x becomes applied to both the numerator and the denominator. So let's say I have x squared over y to the third, and I raise that to the 4th. This is going to become x to the 8th over y to the 12th. So I multiply this 4 times the 2 and times the 3. And anything to the power of 0 is 1. So I could take 500, I could raise it to the power of 0, it equals 1. Yeah.
For the power of a product.
Okay, so in order to simplify a monomial, you have no parentheses left. There's no roots that have not been simplified. Okay, I threw like terms, but it's not, there's no like terms in a monomial, it's just one term. So, but in general, all like terms have to have been collected, and all exponents have to have been simplified, no negative exponents. Okay. So we're going to simplify this. I have multiplication, right? So 2 and 3 match. Put little dots under them. So those are going to be multiplied together. The A's match, so they're going to be multiplied together. And then I've got this B and this C that are just sort of hanging out, right? So when I multiply this, 2 times 3 is 6. A to the negative 2 times a to the third, I'm going to add negative 2 plus 3. So I'm just going to put that in here. You don't have to write this step if you don't want to. And then I have a b squared that's hanging out and a c to the negative 2. So that's going to give me 6ab squared c to the negative 2, but I'm not finished yet because I have a negative exponent. So I have to throw him in the basement because he's negative. I have a quotient raised to a power. I have to take this 3, right? And I have to apply it to the 2, to the a to the 4th, and to the b squared. Okay. So this is going to become negative 2 to the third, a to the 4 times 3 over b to the 2 times 3. Negative 2 to the third is negative 2 times negative 2 times negative 2. So negative 8, a to the 12th, b to the 6th. I have no negative exponents, so, and nothing else can combine or reduce or anything like that, so we're done. maybe add this down there, reduce all fractions. Okay, here I have quotients, right? So technically this is q to the 2 minus 7 r to the 4 minus 3. So it's q to the negative 5 r to the 1. Negative 5 can't stay up top, so that has to go to the bottom. Or you could say that it's 7 minus 2, and the 7 was larger, so it has to go straight onto the bottom, and then 4 minus 3 goes on top. So you can either do get the negative exponent and then fix it, or you can just say, well, the 7 was bigger, so if there was a tug of war between the 2 and the 7 would win, so the 5 ends up on the bottom. Okay, and the degree of the polynomial is the largest exponent sum of a monomial in the polynomial. So you look at all the different monomials that are connected with the addition and the subtraction, right? And let's say I have 3x squared y to the 5th. The degree of this monomial, hold on. The degree of this one is 7. If I have 4x squared, the degree is 2. 3x to the 5th, y to the 3rd, z squared, the degree would be 10. Okay, now if this was a monomial, or in a polynomial, the degree of the polynomial would be 10, because that's the highest degree. So, the degree of this monomial is 7, and the degree of this monomial is 5. So the polynomial has a degree of 7. Okay. Does that make sense? One has no degree. And here's why. It's not a monomial. Or not a polynomial, sorry. And the reason it's not a polynomial is because the square root of x is not a monomial. Monomials can't have roots. Okay, so if you have something like this where you have a square root in it, it has no degree because it's not an actual polynomial. Okay. Technically, that's not a monomial either. Okay, so if you have subtraction, what I first have to do is distribute the negative. So I take this negative and I multiply it by every single thing inside. So this becomes 4x squared minus 5x plus 6 minus 2x squared minus 3x plus 1. So distributing that negative changes the sign of everything inside. Okay. Then I'm going to collect my like terms. 4x squared and negative 2x squared are alike. 5x and 3x are alike, and 6 and 1 are alike. So 4x squared minus 2x squared is 2x squared. Negative 5x minus 3x, they're both negative, so that's negative 8x. And 6 plus 1 is 7. Well, basically, I just get rid of the parentheses because it's addition, so nothing changes. Okay. And then I collect like terms. The x squareds are alike, the x's are alike, and the numbers are alike. So 6x squared minus 4x squared is 2x squared. Negative 7x plus 9x is positive 2x. And positive 8 minus 5 is 3. So the first step is distribute. So I'm going to multiply all of these times 3x. So 3x times 2x squared gives me 6x to the third. 3x times negative 4x gives me negative 12x squared. And then 3x times 6x gives me 18x. The step 2 is to collect like terms if necessary. Well, I have no like terms, so I'm done.
12, negative 12x, 18x. Oh, that's squared, my bad.
Squared. For the table, it doesn't really matter what order. It doesn't matter if I put the first one down the side and the second one across the top, or vice versa. But you make a table, and it's a multiplication chart. So I do n times n squared, that's n to the third. N times 4n is 4n squared. N times negative 6 is negative 6n. And then I have 2 times n squared is 2n squared. 2 times 4n is 8n. And then 2 times negative 6 is negative 12. And the reason the table is nice is because your like terms line up on your diagonals. So what I have is n to the third, 2n squared plus 4n squared, so that's 6n squared, 8n minus 6n, so that's 2n, and then negative 12. It's a modified FOIL. I usually put the shorter one in front. If they're the same size, it doesn't matter. But here's what you're going to do. You're going to take the first term and multiply it by everything in the second polynomial. So I'm going to get n to the third plus 4n squared minus 6n. And then I'm going to take the second term and multiply it by everything. And so I get 2n squared plus 8n minus 12. Okay, so then you collect like terms, so n to the third, I have 6n squared plus 2n minus 12. Okay. Now when it's just a 2 by 3, it's not so bad, the modified FOIL. But when you get into 3 by 3s and 3 by 4s and 4 by 4s and stuff, there's a lot of things to remember to multiply, and so it can get confusing, especially if you're drawing arrows and then there's all these arrows going everywhere. So the larger the polynomial, the nicer the table is, because it keeps everything organized and neat, and so you don't miss anything. Because here, hold on. Examples. Straight distribution. So 2 times 3 is positive 6, and that's going to be a to the third, plus 22a squared minus 40a. I have no like terms, so I'm done. Okay. If you don't like the table, then do the modified FOIL.
No. Give them.
Okay, so we have x to the third plus 4x squared plus 16x, 4x squared minus 16x, and minus 64. Okay. Cancel each other out.
I think
Cancel each other out. Okay. This is a straight distribution, but I'm multiplying by a fraction. So the first thing I want to do is I want to check, does 3 divide into 6, 9, and 12?
Yes.
Yes. Okay, so 3 goes into 6 twice, into 9 3 times, and into 12 4 times. Does everybody follow that? So you divide by the denominator first if you can. So all of these divided by the denominator, so I did. Then I'm just multiplying by 4x squared. Yeah, negative 4x squared. So negative 4 times 2 is negative 8, and x squared times x squared is x to the fourth. Here, let me rewrite it so that it's obvious what I'm doing. Okay, so this becomes negative 4x squared times 2x squared plus 3x minus 4. That's what it turns into. So then when I multiply it, I get negative 8x to the fourth minus 12x to the third plus 16x squared. Okay, this one I get 6x to the third, negative 12x squared, 15x, negative 2x squared, positive 4x, and negative 5. My like terms are on my diagonals. So I get 6x to the third minus 14x squared plus 19x minus 5. But, you know, with the distribution, if the denominator does not go into the whole number, you just multiply the numerator and you get 8 over 3, and then x to the third. When it does, you'll do the division and then multiply. And then again, when it doesn't, you multiply the numerator times the whole number and keep the denominator the same. All right, what you want to do is I'm going to divide each of these individually by this monomial. Okay, so what we have is essentially now, do you have to write this step out when you actually do the problems? Probably not. You can if you want. But essentially you end up with fractions that you have to simplify. Okay, 6 and 3, 6 divides by 3, that gives you a 2. x to the fourth over x to the third, or I'm sorry, over x becomes x to the third. Shh. Y to the third over y gives me y squared. 12 divided by 3 is 4. X to the third over x is x squared. Y squared over y is just y. 18 divided by 3 is 6. X squared divided by x is x, and y divided by y is nothing. It's just 1, right? So it goes away. So when I divide these, again, 20 divided by 4 is 5. C to the fourth over c is c to the third. D squared over d is d. F over f is 1, so it cancels out. 16 divided by 4 is 4. The c's and the d's both cancel out. And you have one f. And then these terms, everything cancels. And anything divided by self is always 1. So it doesn't just go away. Like these didn't, this c and this d here didn't just go away. They became 1s. But anything times 1 is just itself, so we don't have to write it in there. So this doesn't just go away, it becomes a 1. Polynomial long division. All right. You're going to want to rewrite this the same way you do actual long division. Okay. And now what we do is we look at the first term of the divisor. This is the divisor. Okay. And we see how many times okay. Okay, this is the divisor, this is the dividend, and we want to look at the first term of the divisor, and we want to see how many times it goes into the first term of the dividend. Okay. X goes into x squared 1 time, right? Sorry, not 1 time, x times. Right, because x times x is x squared. So x times x is x squared. X times negative 5 is negative 5x. So you multiply that. Right, so I multiplied x times x minus 5. And then you subtract. Just like the steps are the same as regular long division, it's just with weird letters and stuff, right? So if I subtract this whole thing, this becomes negative and this becomes positive. So x squared minus x squared is 0. 3x plus 5x is 8x. And then I'm going to bring down my minus 40. And that's when I'm going to see how many times x goes into 8x. Well, x will go into 8x 8 times, right? So then I multiply again. So 8 times x is 8x. 8 times negative 5 is negative 40. And then I'm going to subtract. 8x minus 8x is 0. Negative 40 plus 40 is 0. So I'm done. No remainder or anything. So my answer if I take this and I divide it by x minus 5, my answer is x plus 8. Okay, sorry. Okay, so you go 3, 2, and then there's none. It has to, you have to have all the powers in the dividend. So I have to have 3, 2, 1, and none. So I have to, I don't have any x's, so I have to put some in there, but I don't have any, so I put 0 of them in there. Does that make sense? So it's just like a placeholder at that point, but you have to have all of the descending exponents. So this 0x has to go here. So that's what I'm going to bring down. Okay, now I'm going to ask myself, negative 5x squared divided by x is what? So I'm looking at this negative 5x squared and this x. So it's negative 5x, right? If I take one x away.
Why are you dividing?
Because it's division, right? So think about, okay, hold on. Think about normal long division. Okay, 3 doesn't go into 2. 3 goes into 27 9 times, right? I do 9 times 3, that's 27. I subtract it. They gave me a 0, so I bring down my 8. 3 goes into 8 2 times. I do 2 times 3, which is 6. I subtract it. I bring down my 1. 3 goes into 21 7 times. 7 times 3 is 21. I subtract it and I have no remainder. We're doing the same process, like the same steps of subtracting, so multiplying, dividing, and subtracting, but we're doing it with variables. So here, this was my 3 times 9 to give me the 27, and then I brought down, but here I subtracted. I didn't have I had an actual remainder. So I bring down the next number. Then I have to say, okay, x goes into negative 5x squared how many times? X goes into negative 5x squared, oops, negative 5x times. And then I take negative 5x and I multiply it by x minus 4. And I get negative 5x squared plus 20x. So that's what goes here. But I have to subtract that. So minus a negative becomes a positive, right? So I get negative 5x squared plus 5x squared, that's 0. And then minus 20x, right? Because it becomes a negative. So I have 0 minus 20, so that's negative 20x. And I have to bring down the negative 24. And then I have to look at how many times does x go into 20x. So x goes into 20x, negative 20 times. So then I do negative 20 times x minus 4, and I get negative 20x plus 80, right? That comes here. Then I have to subtract that. These will cancel out, and now I'm going to have a remainder. Right? Because I have nothing else to bring down. So my answer is going to be 2x squared minus 5x minus 20. And you can either say remainder negative 104, or more properly, we make it a fraction with this as my denominator. Okay, so the dividend is in descending order. I'm listing all of the coefficients of the dividend in my top line. So I list them: 2, 3, -4, and 15. Okay. I draw a line underneath it like that. I bring down the first coefficient right here, 2. Okay. Now, this is r, negative r, actually. Okay. What I need to do is I take this number right here, and I take the opposite of it.
How do you know which one is going to be the one?
It's always going to be this number right here. So it's going to be, basically the format is polynomial divided by x minus r.
Oh,
So whatever sign this is, you do the opposite sign here. Okay? Now, shh, this is of this number, and I put it here. Now what I have to do is I have to multiply. Okay, I don't think you guys can see the L. I take this and I multiply it by this. Okay? And 2 times -3 is -6, and I write that here. Okay. And then I add that. So going down this way, I'm going to add. So this brings me -3, which I'm then going to multiply. Which gives me +9, which I'm going to add, which gives me +5, which I'm going to multiply, and right up there, which gives me -15, which I'm going to add, and that's going to give me a 0. This last number would be any remainder. Okay. So the last number is always the remainder, if there is one. These numbers here are your new coefficients. And your exponent starts with 1 less. So we had started here with a 3. So our answer is going to start with a squared. So our answer is 2x squared minus 3x plus 5. And there's no remainder.
How would we write it in that room?
Okay, so that 0 placeholder, don't forget that. Now I take the opposite, always the opposite. So it's going to be 4. I'm going to draw a line here. And I usually draw a line right here to show where my remainder is going to be, just for myself. You don't have to draw that line there, just have to remember the last number is a remainder if there is one, but I like to draw that line there. Bring down your 2. Multiply, so 4 times 2 is 8. And then I'm going to add negative 13 plus 8 is negative 5, which I'm going to multiply. 4 times negative 5 is negative 20, which I'm going to add. So I'm going to get negative 20, which I'm going to multiply, which is going to give me negative 80. I'm going to add negative 104. So my answer is going to be 2x squared, because I started with thirds, minus 5x minus 20 minus 104 over x minus 4. So the remainder goes over the divisor. And remember, the thing that you're dividing is divisor.
We can do this instead of round division.
My divisor has a leading coefficient that's not a 1. I have to divide everything by that number. So I have to divide everything by 3. So this is going to give me x to the 4th minus 5/3 x to the 3rd plus 1/3 x squared plus 7/3 divided by x plus 1/3. Synthetic division, you can't have anything other than a 1 right here. Okay, so if you're doing synthetic division, you have to divide everything by whatever number this is, which can give you whatever fractions it gives you. Now, I bring down my coefficients. I have 4, 3, 2, oops, there's a 1 right here, sorry, there's an x. 1, and then none, so plus 0 on the end. So I have to bring down my coefficients. So 4, 3, 2, 1, none. And my opposite is negative 1/3. Bring down my 1. Negative 1/3 times 1 is negative 1/3. That gives me negative 6/3, which equals negative 2, right? Bless you. Here, hold on. Which is the same thing as negative 2. So I do negative 1/3 times negative 2, which gives me positive 2/3. When I add those together, I get 3/3, which is 1. So I do negative 1/3 times 1, which gives me negative 1/3. When I add these together, I get 6/3, which is 2. Negative 1/3 times 2 gives me negative 2/3, which is my remainder. So my answer is negative 2x to the 3rd. Oh wait, sorry, that's, yeah, plus x squared plus 2x minus 2/3. Okay. Over x plus 1/3. Sorry. Okay, so you have to deal with all these fractions. To divide that leading coefficient, you can just leave it there. I'm gonna put that plus 0 on the end there. So what I do is I say 3x goes into 3x to the fourth, x to the third times, right? So x to the third times 3x to the times 3x, excuse me, 3x to the fourth, and x to the third times 1 is x to the third, and I subtract that. And this gives me negative 6x to the third. Shh. Guys! So I bring down my x squared. And I say 3x goes into negative 6x to the third how many times? Negative 6x squared times. Not 6. Sorry, not 6, not 6, not 6. 2. Yeah, 3 times 2 is 6. 3 times 6 is not 6. Okay, so when I multiply that, I get negative 2x to the third squared times 3x gives me negative 6x to the third. And then negative 2x squared times 1 gives me negative 2x squared. And then I subtract that. Those cancel, and I get 3x squared. Bring down the 7x. 3x goes into 3x squared x times. Multiply those. Subtract it. Bring down the 0. 3x goes into 6x 2 times. 2 times 3x is 6x plus 2, so I have a remainder of negative 2. So my answer is x to the third minus 2x squared plus x plus 2 minus 2 over 3x plus 1. That's my remainder up there. I did not have to deal with any fractions. So it's up to you. You are allowed to use either synthetic division or long division. You probably, if you don't like fractions, will switch back and forth between the two. Maybe you'll only use one, maybe you'll only use the other one. As long as you divide it and give me the correct answer, I don't mind which one you use. So, having said that, your homework is the basic polynomial operations. And that's odds. And then you have adding and subtracting polynomials. Odds. Multiplying polynomials. Odds. Actually, let's change these to, okay, and then dividing polynomials. Odds. There's another one in here called multiplying special case polynomials. We're not going to do that for homework yet, okay? We're going to talk about that on Wednesday. And let's change this, instead of odds, let's do every other odd. Odd for all of them. Okay. So you're going to do the operations, adding, subtracting, multiplying, and dividing polynomials, just not the special cases, and you'll do every other odd. Any question about every other odd?